Okay, so I'm going to pick up where we left off yesterday, and I'm going to just quickly go through the slides just to refresh your memory where we were. Okay, we were classifying numbers in the real number system. Any questions about that? Oops. Okay. Man, bright colors. I'm excited. So who's at the top of our family tree? Grandma Real. Okay, Grandma Real is at the top of our family tree. Every number under this family belongs to who? Well, all the numbers, even rational and irrational, belong to Grandma Real. From there, you can put them into two separate families. You can either say every number has to be real, agreed? And then from there, you're going to put it into rationals family, or you're going to put it into irrationals family. Okay, what was the definition of rational? Any number that can be written as a fraction. Okay, so what kinds of numbers can we write as fraction? What kinds of numbers went in our bubble down here? Mixed numbers, round and scoot, right? Whole numbers. 3 is 3 over 1. 4 is 4 over 1. 5 is 5 over 1. Okay, what else? Integers. What are integers? Whole numbers. There you go. Positive and negative whole numbers. Okay, so it's not any positive or negative number. They have to be whole, but they can be either positive or negative. Give me some examples. Give me an example, Jessica, of an integer. -3. Izzy? 1. 5. -2. Very good. How do you make 5 a fraction? How do you make -3 a fraction? Okay, so we got integers, we got whole numbers, we got mixed numbers. What else we got? Percents. Okay, perfect square roots. Ooh, perfect square roots. Give me an example of a perfect square. Nate. 49. 49 is a perfect square. Why is it a perfect square? Because it's the square of a whole number, 7 times 7. And when we reverse that and take the square root of 49, you're going to get square root of 49 is 7, and that belongs in rationals family because 7 can be 7 over 1. So very good on that. We got percentages, so integers, perfect square roots, terminating decimals. Give me an example of a terminating decimal. 0.3. 0.3 is what as a fraction? 3 over 10. Remember, the terminating decimals are the ones that end because they have zeros after them. And you look at the place value and put them over 10, 100, 1,000, whatnot. Okay. Then we have percents. We got mixed numbers. Give me an example of a repeating decimal. So 0.123, and so what place value does that go over? It goes to the thousandths, but I told you it didn't go over 1,000. If it's repeating, it's going to go over one less than that, right? So it's 123 over 999, right? Because it's one less than 1,000. Okay, so all those can be made fractions. And then you came over here to what I called as my family, okay? And I said my family looks the same. What do they look like? They look like non-repeating, non-terminating decimals. What does that mean? And it never ends. Remember, it goes out the door, down the hallway, across the street, past Hardee's, up Main Street, and circles globe 3 times. And keeps going after that, right? Okay, it just keeps going and going and going. But besides the fact that it just keeps going and going and going, what else? It doesn't have a pattern. Okay, so it's like 2.76513 random numbers everywhere. Okay, does that make sense? No pattern to it. So give me an example. Pi is one of them. Very good. And where's the other place that we get one? Where did we find them in our calculators yesterday? From non-perfect square roots. Very good. Okay, give me an example of a non-perfect square root. Okay, here you go. Give me an example of a perfect square root. 16. Square root. Oh, uh-oh. Do I have a pen? can do that. There you go. Square root of 16 is 4. These are all rational. Okay, and you don't need to write these down. I'm just reviewing. Give me an example of a non-perfect square root. Give me one that I didn't give you yesterday. Give me a new one. Square root of 172. Everybody put that in their calculator. Square root of 172 gives us what? And if you don't know how to put in the square root in the calculator, find a neighbor or ask Miss Handy and she can show you. 847705 ... And again, why do I put a ... The calculator just stops it, okay? But it actually doesn't stop. Remember, it goes out the door, down the hallway, across the street, past Hardee's, up Main Street, and circles the globe 3 times. I like to say that a lot. Does that make sense? And it keeps going forever, never, never. Is there a pattern? No. This belongs in whose family? This is irrational. And remember, what did I say yesterday? If it does not look like this, then obviously it does not belong in my family. Red-headed, freckled, and fair-skinned. Does that make sense? It does not belong in my family if you don't look like that. Okay? Everybody okay? All right. So then I gave you a list of 6 choices. Okay, these are the choices you're going to use for your answers. How do we know if a number is real? All numbers in Algebra 1 are real. Okay, so everything's going to be real. Then you have to decide, is it rational or is it irrational? And what did we talk about at the very end of class yesterday? Rationals can be a fraction, and irrationals can't, because remember, if it don't stop, we can't determine a place value. Okay? Okay, and we said that, could it be in both houses? No. I said, remember my little Sadie? I love her to death. She can come over to my house and play anytime she wants, but in the end of the day, how many mamas does she have? 1. She belongs to my sister. Okay? She can only be in her household. Okay? You got to stick with me on that, because I know some people are like, well, what about this and what about that? And, you know, stick with me. She belongs to my sister in her household. She can't be in 2. Okay? So it's either one or the other. Okay? One or the other. How do you know if a number's whole? Starts with 0 and goes 1, 2, 3, 4. I said, remember, think kindergarten. Okay? My Reed, he has no clue about negative numbers. So -2 and -3 are not whole. Okay? Whole numbers are just the basic numbers you learn in kindergarten. 0, 1, 2, 3, 4, 5. And they have to be positive. And we said integers have to be whole, but they can be either positive or negative. The technical definition is that it is a whole number, which are your positives, and their opposites. And the opposites would be the negatives. Okay? And then, what did we say about natural numbers? Starts with 1, so it's a little different than whole. Remember, wholes include 0. Natural start with 1. It's what you count by. If I said, Dylan, count for me the students in the class. Start over here. Ready? Go. 2, 3, 4, 5, 6. Very good. Okay, so if you can count to it, it's a natural number. And those are the choices you're going to use. So, everybody okay so far? Everybody remember where we're at? We got to example 4. I'm going. Got to get used to this new little board here. It's a little different. Okay, let's take a look at, we've already done these examples. Again, if you missed them yesterday and if you're lost on anything, it will help tremendously if you can watch the video. If not, just borrow somebody's notes and do the best you can. So, let's take a look at the square root of 17. So, if I give you something to do, like an operation of some sort, or if a fraction needs to be simplified, then you need to go ahead and do what it says to do. You with me? If it asks you to add something, subtract something, take the square root of something, you need to go ahead and do that first, and then look at your answer and describe your answer. So my question is there something to do up here? Yes. I don't want to describe 17. I want to describe the square root of 17. So in your calculators, find out what the square root of 17 is. Dot, 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 right? It keeps going forever and ever and ever. So here we go. Start at the top. And I recommend when you, how many of you have, most of the time, you take notes and then you put them away and you never look at them again? Okay. This little list of choices that I gave you, I want you to have those out. Your little family tree, I want you to have those out. And so here's what I'm going to tell you. Every single one I do, I'm going to go down the list. Don't skip around. If you go to natural and then you go to real and then you go to rational and then you go to whole and then you go to, you with me, and you skip around, what's going to happen? You're going to miss one. Does that make sense? You might get a couple of them right. So here's what I'm going to say. Go in order. Go down the list. So let's start at the top of the family tree. Is it real? Yes, it is real. Then let's decide whose house does it go in. Is this rational's house? Can it be made a fraction? Or is this irrational's house? Irrational. Very good. This is red-headed, freckled, and fair-skinned at its finest. Okay? Irrational. Okay? So if it's irrational, we can put the rational away, right? Let's go down. Is it whole? 17's whole. But 17's whole. I'm not looking at 17, right? Are you back with me? Okay. I'm not looking at 17. I'm looking at the answer. Okay, does that make sense? Always look, if it asks you to do something, do that operation and describe the answer. Okay, so it's not whole. Is it an integer? I thought integers were negative or positive. That's positive. It's got to be a whole number too. Very good. Okay. Do we count by that? No. Okay, so pretty much here's what I'm going to tell you. If it's irrational, then what do you know about all the rest? If it's going to be one of them decimals, will it be a whole, an integer, or a natural number? If it's irrational, it's just going to be those two. Okay, remember, at the end of class yesterday, we said that it had to be real. Was it Landon that told us this? And it had to be either irrational or rational. So it's going to be at least two answers, okay, on every single one. All right. How about this one? Is there anything to do up there? Yes. And again, when I throw that negative out, here's what I'm going to tell you this. And we haven't covered negatives yet. But I don't care if I write this or if I write this or if I write this. Is that all the same thing? Let's just review really quickly. What's a negative divided by a positive? A negative. What's a positive divided by a negative? A negative. That's a negative fraction, right? This says negative 25 divided by 5. What does it simplify to when you divide 25 by 5? Negative 5. What do you get when you divide that? Negative 5. What do you get when you divide that? It's still the same thing. Okay, so it doesn't matter if there's a negative out in front of it. The whole fraction is just negative. So don't let that confuse you. Okay, so when we simplify, if there's something to do, then we simplify this. Okay, why didn't we simplify example 3? Because it can't simplify. It's already reduced. Does that make sense? So again, if it's already reduced, just leave it. If it's not, though, go ahead and simplify it because there's a lot we can say about negative 5. Here we go. At the top, is it real? Yes. Whose house? Rational or irrational? Rational. Why? because it can be a fraction. That's the key. Negative 5 over 1. It's rational if it can be a fraction. Okay? Because that's the definition. Okay? Is it whole? Why is it not whole? Because it's negative. Remember, wholes, we're in kindergarten. We don't know negatives yet. When did you learn negatives? Like, yeah, 4th, 5th grade, something like that. Somebody said last year. That's what somebody in another class said last year. Okay, like 4th, 5th grade, somewhere in there. But you know, whole numbers, that's what you learn in kindergarten. You don't know negatives yet. Those are all positive. Is it an integer? Yes. Remember, integers can be either or. Do we count to negative 5? Is it natural? 1, 2, 3, 4, negative 5? No. Okay, why don't you try these two on your own? Oops, I'm not doing very well here with my little board. Try this one. Actually, I'm going to give you a 9. And let me think of one more. Let me ask that again one more time. Is there something to do on example 7?
Yes.
Yes. What is it? To take the square root of 81. But here's the thing. How many put it in their calculator? You have to be very cautious, careful, and conscientious when you put it in your calculator. Is the negative on the inside of the radical or on the outside? On the outside. Do me a favor real quick. Put it on the inside. The negative button, by the way, is on the bottom by the decimal down here. Okay? But put in the square root and put negative 81 on the inside of the radical. And tell me what happens in your calculator. It doesn't work. What do you get? You get error. Non-real answer. What does it mean to be a non-real answer? Remember I said there are certain answers that are not real. What are they? They're imaginary. And I said, don't worry about those for Algebra 1. You don't need to worry about those. But here's the thing. I didn't give you an imaginary answer problem. Okay? I put the negative on the outside. So just make sure, just be careful when you punch it in your calculator that you pay attention. Okay? What this really says, this is like a grouping symbol. And so you do this first. What is the square root of 81? 9. And then what do you do with the negative? Just drop it down. Does that make sense? So the answer is really negative 9. Tell me about negative 9. Raise your hand. Go, Ryan. Start at the top. It's real. It's rational. And it's an integer. Okay? All right. How about example 8? Question? No. Okay. You got it? Example 8. Is there something to do on example 8? Does it need to be simplified? No. So what did I say do? If it doesn't need to be simplified, do I want you to change it to a decimal? No, just leave it. Again, do you understand the difference? This could be simplified, but this can't. So if it can't be simplified, just leave it. Go, Grace. It's real and rational. And that's it. Okay, it's not whole. It's not an integer. We don't count by 7/18. Okay, does everybody understand the difference between those that you can simplify and those that you can't? If you can't simplify it, just leave it and describe it. Okay? All right, somebody different, the last one, 8. Is there anything to do with 8? No, so just leave it again. So, tell me about 8. It's real. It's rational. Anything else? It's whole. It's an integer. And it's natural. Very good. Oh. How about that? I get going. Any questions? How many feel good? Confident? Good. Okay. So I would like for you to try these for me. And this does work this time, I promise. I know last time I gave you book work. We actually are in chapter 0. Please